Well, good morning. Thanks for the kind introduction. This is indeed a challenging topic that I try to address in the context of systems modeling, as we all do it. What are we actually after? When we heard Simon Levin earlier this morning, he used the notion of more desirable futures or more desirable state of the system. Jill Jaeger just talked about solutions, but solutions to what end? What is the vision? Where do we want to be? Which is not an easy question, and given that I'm a demographer and also did some philosophy, as was mentioned, you will not be surprised to see that I think this sustainability criteria have something to do with human well-being. But I first wanted to go back a step in IIASA history. You heard something about the history, but in terms of sort of the applied systems models, the first decade at IIASA really was a decade where a lot of global modeling. Actually, IIASA was the center of what's called global modeling at the time, which were not just the limits to growth and follow-up studies, but also Bariloche and some other big global studies. And actually, there was a IIASA book published by Daniela Meadows and Gerhard Bruckmann, with the title, Groping in the Dark, the First Decade of Global Modeling. Well, I was interested to see there never was a book on the second or the third decade of global modeling, because this big-scale global modeling came out of fashion. For good reasons, because these were very crude models, and people had serious doubts how closely these crude models really matched the complex realities of our planet. So at IIASA, we first went then on to sort of sectoral models on the energy, on the air pollution, on the population, and so on. But my first involvement in systems analysis after coming back from the US to IIASA really was engaging in a new attempt of global modeling, but at a very small scale. I thought if we can't address these issues on the global scale, why not look for a place, a small island with excellent data, high population density, and so we did a case study on the island of Mauritius that actually involved not just the population people, but I mean Marcus Ammann and Ferenc Todt and some environmental people there were also actively involved in this study. And in asking in terms of sustainability criteria, at that time in Mauritius it was very one-dimensional. I mean, this was a country really coming out of desperate poverty, having now the fertility decline, some improvements in education, and now slowly they increased their income mostly through export-oriented textile industry. And they were doing quite well, but they also had these beautiful lagoons, and as you know, in the textile industry, you have dye houses with lots of heavy metals into the lagoons, and so there was a real danger that they would permanently damage the lagoons, but they didn't care. I mean, they wanted more income. That was a one-dimensional target, and it was some of our models where we showed them that this is, of course, a bad thing for the long-term future, and actually they, at that time, also established then an environment ministry. But what really helped us was that at that time, tourism just started in Mauritius. And of course, the tourists wanted to see unpolluted lagoons, and they were willing to pay more than the profit they could get out from dirty dye houses. So that was sort of one economic incentive. But just stepping back a little, and so at the time, this whole issue of population, human factors, and the environment typically was done in terms of what I call the box approach. People in their numbers, in their behavior, affecting the environment, like this famous IPAD equation or the Kaya equation was a typical example for this. Some people like for instance, the limits to growth. They also looked at what is the feedback from environmental change onto the human population, such as increasing mortality. But of course, the human population doesn't exist outside the laws of nature. So what we really need to have is an embedded view where we, the humans, really are part of the planet, part subject to the laws of nature, and then creating around ourselves some sort of built infrastructure that we call development, but we really need to be more detailed. So this was also still from the book that we did on Mauritius, sort of this comprehensive model. And you see this one sector, that is, even if we're doing systems analysis at IIASA, typically we're only looking at, let's say, of two linked systems, let's say the water system here with the human population system. But of course, there are many other systems here. And in some cases, we do energy and air pollution joint analysis, looking at the co-benefits, and some of these issues were mentioned. But to really have the comprehensive, some people would say holistic view of this is a real challenge. And then even more so is sort of what developments of this whole comprehensive system are we after. Now, this sort of study of the PDE, this population development environment studies, were followed by another series of applied studies, models that were called the PEDA, mostly looking on agriculture, development, modeling for several African countries, systems models, really applied systems models of what was that time what called the vicious circle, like rapid population growth leading to changes in the land use, land degradation, diminishing agriculture production, feeding back negatively on human well-being, on mortality, on the food security status of people. And so there was a lot of this modeling done. And sort of in these models, it was really people starving. That was sort of one of the things that we wanted as a target to avoid. But also income was another output parameter. Now, more recently, in the context of putting the climate change topic prominently, we drew this circle where, again, we have the human population both consuming and causing the CO2 emissions, but at the same time, it is us, the human beings, who have to come up with solutions, with innovation, with new technologies. But this is sort of on the left-hand side, you see what we call the mitigation side. Much less emphasis has been given, and that's what also we in the population program over the last years had a closer look at. How does climate change affect human well-being or human life or the human number? So what is the feedback from climate change to the human population? And of course, you can have all these on temperature, humidity, extreme events, sea level rise. These are all different dimensions of climate change. And what we really have to stress here is that not all people are the same. The human population is not homogeneous. There is indeed everywhere what we call differential vulnerability. People are to different degrees vulnerable to these changes. And this vulnerability is reflected in their livelihood, that again may reflect their health and possibly mortality. It may cause migration. So there are all these interconnections here, how human populations subdivided by age, by gender, level of education, place of residence, or several other factors are differentially affected by this. And this really needs to be considered in our analysis. And actually, IIASA has a recent cross-cutting project looking precisely at this population heterogeneity, also in many of the other IIASA models, where we don't just assume a uniform, homogeneous human agent. Well, this view sort of is directly reflected in these new shared socioeconomic pathways. Jill has already briefly mentioned this collaboration among many global change research institutes in the context of the IPCC, and many IIASA programs have significantly contributed to this. And so these two dimensions really show what I showed before, is on the one hand you have the mitigation side, so you are trying to address the socioeconomic challenges for climate change mitigation, and on the other axis you have the socioeconomic challenges for adaptation. And then you fill this room with 5 scenarios, where the SSP1 is sort of the best world we can think of in terms of having the mitigation and adaptation challenges at the lowest possible, and the SSP3 on the other hand, it's called fragmentation. You have sort of a freezing of current differences where it's both difficult to mitigate the greenhouse gas emissions, and it will be a major challenge for societies to adapt to already unavoidable climate change. Well, we have recently converted this into alternative population scenarios, and at this point I should mention another Harvard professor emeritus who came to IIASA leading the population program for 10 years from 84 to 94, and this major more than 1,000-page volume that recently came out was dedicated to his 100th birthday, because he really has set also the methodological foundation of this multi-dimensional population modeling, which goes beyond modeling the population size and then broken down only by age and sex, but you can have additional dimensions considered, and these dimensions are indeed very relevant. So what we have here are scenarios, and SSP2 is sort of the middle of the road, you may say the medium scenario. And so this is aggregated for all countries of the world together, but this exists on individual country level, these scenarios. And in addition to the human numbers, you have here in color the highest level of educational attainment. So you see today in red people who have never been to school, and there still is about a billion of such people. Paul Collier calls it the bottom billion, mostly in Africa, some in South Asia. And then there is about 1.5 billion of people who have only primary education. And then you see a high proportion of people that have at least a junior secondary education. And then on top is the post-secondary in dark blue. And in the middle of the road scenario, actually, we see further progress in education. And partly this is already embedded because in most countries of the world, the young people are already better educated than the older ones. So as time passes, they just move up the age pyramid and get better educated. So that's why you see this expansion of the blue, particularly dark blue. And in this scenario, you also see a peaking of world population at around 9.5 billion people, up from currently 7.3 billion during the second half of the century. Well, but this is only one scenario. The SSP1, which is sort of the more rapid socioeconomic progress scenario, you see a much faster expansion of the blue area of the more highly educated. You still see the red diminishes, but does not completely disappear, because education mostly takes place at young age, and if you have some uneducated people, they will still continue to live on for decades into the future. So even under this higher education scenario, you still have uneducated or people with low education. Also because higher education universally leads to lower fertility. You see sort of a peaking of the population at already 8.4 billion and already by the middle of the century. But then we have the SSP3, and here you see little progress, stagnation, not much progress in educating, particularly in Africa and South Asia, expanding the education. So here you see almost constant proportions at the different education levels, and you see the world population increasing rapidly to more than 12 billion by the end of the century. So these are really sort of three different consistent, theoretically possible, but very different futures for this planet. And coming back to the sort of criteria, of course, here sort of implicitly the interconnections between socioeconomic development, education, health, economic growth, they are sort of put together, bundled, so to say, in these scenarios. Yes. Now, talking about the systemic view, in the disaster and risk vulnerability community, where this is essential that if we want to see how dangerous is climate change for human well-being in the future, natural disasters is one important aspect. And we looked at it as this issue of education as a possible protecting force, possibly reducing disaster vulnerability because people are better prepared, they can better anticipate what's happening, and they also recover more quickly after the disaster, had not been a topic. So it was a new question to be put on the table. We actually had partly asked people to go back to their surveys and collect additional information on education because they had only asked for income and how the house was constructed and so on. So we have this special issue in ecology and society, really showing that once you broaden the scope, take in an additional dimension such as education, the picture looks really very different. And we recently summarized this a year ago in this piece in Science on the title Universal Education is Key to Enhanced Climate Adaptation. And many people thought this as sort of really a new dimension, possibly the way like Pavel talked about this, the Shakespeare text in his introduction. If you put on a new lens, an additional perspective, all of a sudden the meaning, the priorities change completely. And just to put this into concrete terms, you all know that there is a green climate fund now in Paris. It will be decided how much countries will actually pay into it. The goal is having $100 billion per year. And some of the money is already on the table and being spent, and we looked, where does the money go? And it really is mostly onto sort of big engineering projects, building seawalls, irrigation systems, and so on. Well, in this piece, we claim that maybe the money should less be spent on concrete activities in the double meaning of the word concrete, like putting massive infrastructure, which is also very specific, but rather empower people to flexibly react to the still uncertain future conditions that climate change may bring to them. And that's why then Editors at Science magazine put this subtitle that has raised quite some reactions from engineers. They said, fund more educators rather than just engineers. We are not saying that no money should go to engineers, but at least education as empowering people could be added to this. Okay, but when is adaptation successful? This brings us again back. Why are we trying to adapt, and what are the criteria for sustainability in systems models? And that's clear that really different people have different values, they have different preferences, and different views of what is being desirable. Of course, you can partly go out and ask people, you can have stakeholder involvement, as it was mentioned, but for instance, people who are not yet born, the future generations, we can't ask them what are their values. And there are also limits to get out of the minds of people, and we just heard in the previous presentation. It really depends sort of what is the context for asking such questions. So I don't think having a sort of completely relativism is the only option. The question is, do we find some sort of a broadly agreed view of some very basic criteria of what is a desirable development and what is to be avoided? And if so, how can we get there? Well, in trying to think about this, going to really to the basics, I mean, one thing that most people would agree to is that survival, which means being alive, is clearly a prerequisite for enjoying any quality of life. So if you are dead, you cannot enjoy quality of life. And this is probably one of the few things that most people have in common. If you can think of a Wall Street broker, a subsistence farmer in Africa, or a Buddhist monk, I think all of them would prefer to avoid premature death of their family members or of themselves. But at the same time, you have to say that mere survival is not considered enough by most people. So you want to develop an indicator that I sort of tentatively call empowered life years. Being alive and being empowered to enjoy and do what you want to do. And in this context, I found it really helpful, an approach that Bill Clarke presented, and his slide that he put up 3 years ago at the IIASA conference in 2012, proposing this function where the dependent variable, W, is human well-being, intra- and intergenerational. And then he defined a set of capitals, sort of the manufactured capital, the human capital, and the natural capital, together with institutions and knowledge. I think that is the challenge, of course, is to operationalize this concept. So you have to both operationalize the right-hand side of the equation, but also look at sort of how could you possibly measure this W? And here, putting this to work, I started working on this, but at the bottom you see sort of different aspects of empowerment that may be useful. It could be the health status, it could be functional literacy, being able to read and write and communicate through words, written words. Then happiness was mentioned, that clearly is one aspect, more objective than the subjective well-being is being out of poverty. So this reminded me of a work I had done with my IIASA colleague Engoujon about 20 years ago in proposing an indicator that we called literate life expectancies. So this is combining survival with empowerment through literacy. And it can be clearly measured as the years a person is expected to be alive and able to read. And this is a life table. For those of you who have seen it, you see sort of the highlighted yellow column is the life expectancy. This is pure life expectancy. So rural Egyptian men in 1986, this was our data, they had a life expectancy of 58 years at birth, and then once they survived the first 5 years, it went up to 62 years for the remainder. So what we now did, we weighted this big LX function of the person years lived with the proportion literate at each age, and then on the red you see literate life expectancy, which is much lower, of course, for Egyptian men, rural men in 86. This was at the order of 24 years at birth and then 27 at the age of 5, because only a few of these life years that were lived were actually lived in the state-empowered literacy. So this is a very useful development indicator, and actually the UNESCO Institute of Statistics was very interested in using this, until at some point they said, no, we don't want it because it mixes the education dimension with the health and survival dimension, and we don't want this. Well, so far to the international organizations that are very narrow, sectoral in their focus, I think here in systems analysis, precisely what we want, mixing and merging, blending in a meaningful and interpretable way these different dimensions. Just empirical data, this literate life expectancy really increased for most countries in the world. This is North Africa, this is Sub-Saharan Africa. But there you see two lines, men and women in South Africa, actually declining after 1990. And this is the AIDS epidemic that caused the decline in survival probabilities. Okay, now coming to a conclusion, the time is almost up. Of course, I only showed you this literate life expectancy. There are other good candidates. The first one clearly is healthy life expectancy. That is already measured, and WHO and the Global Burden of Disease have good data on this. So it's not only being alive, but being alive in good health. Then you could equally, following the same principle that I just showed, do out of poverty life expectancy or even happy life expectancy, taking sort of the subjective happiness scores that you have from surveys. Or you can have any combination of them. And then when you really want to operationalize it, a possible criterion is that one of these chosen indicators should not decline over time in any subpopulation, after all these feedbacks from environmental change and economic change or whatever you want to consider are taken into account. But clearly, it started out saying different people have very different views. We have to do more empirical analysis, what people value, and also develop both the left-hand side of the Bill Clarke's equation as well as the right-hand side in more detail. But in the end, I think this is a question that we cannot avoid. In any sort of policy dialogue or communicating our results of systems analysis, we have to be more transparent and more explicit of what are the criteria of sustainability. Thank you very much.